Hi, I'm Florence Dowrick, a MajorTim.space honorary young ambassador, and this is Oliver Ukereghe, a MajorTim.space young ambassador. Today, we are interviewing Dr. Anjana Khatwa. Anjana, could you please introduce yourself?
Oh, thank you for having me. Yeah, I'm an earth scientist, and that's basically what that means is that I tell stories about rocks, fossils, and landforms.
Okay, I'll lead with the first question. You call yourself a time traveler who explores ancient rocks and fossils. What would you say has been the most significant research you have conducted about Earth's past?
Oh, that's a really difficult question because Earth is about 4.5 billion years old. And when I was in my research career, I was working at with the very youngest rocks on Earth. So those that had been deposited during the last ice age about 10,000 years ago. Now, over the last kind of 20 years, I've worked very much in a period of time called the Mesozoic period. This is the Triassic, the Jurassic, and the Cretaceous periods of
Mm.
time, and they range from 250 million years ago to about 66 million years ago. Now, I was at the Jurassic Coast doing this amazing job where I was leading on learning and education there. So some of my really interesting pieces of research have all been about how do we talk about deep time to people from all sorts of different backgrounds so that they have a sense of understanding about how our earth has evolved and changed over time.
Thank you. Oliver, would you like to ask the next question?
Sure. What first sparked your interest in geology?
Well, I was about 13 years old and I was on a trip to see my family to Nairobi in Kenya. And I grew up in Slough, which is a town just outside of Heathrow Airport. So it's not a place you go and see lots of rocks, to be honest. It's covered in a lot of concrete. So my parents are from Nairobi, and that's why I was in Kenya as a teenager. And it was on holiday there that we were traveling all over the country, seeing all sorts of amazing landscapes and animals and wildlife. But it was on a journey from Nairobi to Mombasa where we were traveling across really amazing landscapes, and we stopped off at a place called the Shaitani lava flows. And this is like a really amazing place. It's in the East African Rift Valley system. What this means is that you've got two plates, the African plate and the Arabian plate, and they are pulling apart very, very slowly. And as the two plates pull apart, the crustal rocks in between drop down. And this is called a graben. So as these crustal blocks drop down, you get all sorts of volcanic activity happening because the crust is rifting apart. So because of this, you get volcanoes and all sorts of eruptions. So I was traveling with my family and we stopped off at a place called the Shaitani lava flows that were formed about 300 years ago due to volcanic eruptions. And I was walking over this amazing landscape that I'd never ever seen before. You know, the rocks are like these really dark black color, they're really jagged and sharp. And as I walked over them, I just had this amazing sense that this was once a landscape covered by, churning rivers of lava. That, if I was standing right there, I'd be like melted away in the heat of this molten rock. And on that very day when I was 13 years old, I picked up this rock. I'm just going to show it to the camera. There you go.
That's
13. And you
cool.
know what? I still have I've still got this rock today, and I'm now 50. And what's amazing about this rock is that when I picked it up, I was 13. I knew I loved science. I really, really loved science. And at that age, I really wanted to work for NASA and be an astronaut or something like that. But when I picked up this rock, I just kind of changed my mind because I thought rocks are amazing. They have these amazing stories. And I kind of made a promise to myself. I thought, I'm going to leave with this rock. And one day I want to be the person that tells the stories about these things.
That's really interesting, actually. This is random. If you think that rock specifically could talk, what would it say?
Oh, I've actually written about this in my brand new book, in one of the chapters, and I'll show you my book. It's called The Whispers of Rock. There we are. Sorry, it's the wrong way round. But in chapter 4 of the book, the rock actually tells its own story. So what this rock would say to me is that it's so lucky that it's been found by me and it's had a chance to make my dreams come true. That's what it would change. That's what it would say.
That's really cool. If you could visit any moment in Earth's history, for example, when dinosaurs roamed, the Pangea supercontinent existed, or volcanoes first erupted, where would you go and why?
Oh, that's a tough one. I think, do you know what? I think I'd go back to the Carboniferous period, which was around about 380 million years ago. So it predates
Mm,
dinosaurs.
yeah.
And the reason for that is because the climate, the weather was really nice and warm, and I'm a real hot weather person. But also, this was a time when there was lots of oxygen in the atmosphere, and this meant that trees and plants grew to enormous proportions. But also, so did the animals, so did the insects, so did the dragonflies. And the key thing about the Carboniferous period is that there was so much oxygen that these insects, particularly the insects, they grew so large that you had dragonflies the size of car tires. And I would love to go back and see insects, like giant insects, millipedes about,
Yeah.
2 or 3 meters long, crawling through a forest. I would love to see that.
You have
Oliver, would you
written
like to
about
ask the next question? Oh, sorry, did I interrupt you? You can go.
you've written a book about you've written a book called The Whispers of Rock, which was published in the UK in September. Could you tell us about the publication process and whether you have any other works in process?
Right, yeah. So here is the book. This is the UK edition, and tomorrow, which is going to be the 4th of November, the
Ooh.
US edition comes out as well. So I've got two books coming out. This is the American one, and this is the British one. Now, to get a book like published like this takes a long time. You have to be an expert in your field. So obviously I've had about 25, 30 years working as a geologist in all sorts of different places all over the world. And the other thing you have to do is have a really good idea, because when you start to sell your idea to literary agents, and particularly your agent then talks to publishers when he wants to sell the book, your idea has to capture their imagination. And this book, the really unique story about my book is that it tells the story of the creation of our world through all sorts of different ways of knowing. So it tells a story of how scientists understand the way the world
Mm,
was created, but it also tells a story of how indigenous people across the world believe that the rocks and the landscape were formed around them. And I also bring in my own experience as a geologist into that mix. And that's what really attracted the publisher, because I bring a lot of feeling and love and emotion into the book, and that brings the stories of rocks alive.
you are very peripatetic in your career. Where is one place you would love to visit to study geology that you have not yet had the chance to?
Oh, that's a really interesting question, because I can tell you all the wonderful places that I've been, but the one place I haven't yet been is Japan. And the reason why I'd love to go
Ooh.
to Japan is because in the first chapter of my book, I talk a lot about how the indigenous religion of Japan, which is called Shintoism, it believes that every aspect of the natural world is imbued with a spirit, and the Japanese call this kami. And a volcano or a rock or a river or even a tree, every single aspect of the natural world has a spirit that governs how that part of nature behaves. And so volcanoes, when they erupt, they're an expression of Mother Earth expressing herself. And the other thing about Japan that I find really interesting is geologically, it's a place where you
Mm,
have enormous mountains, you have active volcanoes, but it's also an earthquake zone. So I'd love to kind of visit the country to see
yeah.
how the Japanese live alongside all of these natural hazards and threats, but also how storytelling and their kind of spiritualities help them to be more resilient when they're facing really difficult things like that.
Where would you say is the most interesting or important geological site in the world?
Well, there are special places all over the world that mean that those landscapes must be protected now and for the future, for everyone, forever. And they're called UNESCO World Heritage Sites. And I've been really lucky because I worked at a UNESCO World Heritage Site for about 15 years. It's called the Jurassic Coast, and it's in Dorset in East Devon. And when I worked for World Heritage, I kind of got to know so many different places all over the world that are really important for the geology. Out of all of them, I'd say it would be the Jurassic Coast, because this particular piece of coastline, which is on the south coast of England, it's about 95 miles long. It records 185 million years of Earth's history. So what the rocks tell us is the evolution of life and landscapes from 250 million years ago all the way through to 66 million years ago. And what you see in the rocks is a story of how ancient deserts transformed to deep seas with all sorts of incredible marine reptiles, all the way through to lagoons and swamps where dinosaurs walk the earth. You can't see that anywhere else in the world. And the most incredible thing about the Jurassic Coast is you can walk along the coastline and see those rocks for yourselves. And you can also find the fossils, so you can hold a fragment of ancient life in your hand. That's why I think it's so amazing.
Yeah, that sounds really awesome. I haven't been, but I've heard a lot of stuff about it, and it just sounds really cool. Have you ever formulated a hypothesis that didn't work out the way you expected, and what did you learn from it?
Oh, I'd have to go back to my research days, and I was researching how glaciers and ice sheets sat upon soft sediments at their base.
Mm.
And the hypothesis I was kind of coming up with was, well, if climate change is causing glaciers and ice sheets to melt, that water will infiltrate and soak into the very muddy sediments at the bottom. And this will cause a glacier or the ice sheet to flow faster and collapse. And that was a theory, that was a hypothesis I kind of started my PhD with. And in fact, what happened was I did lots of analysis of the geology underneath ice sheets and glaciers. I looked
Mm.
at ancient kind of sediments that were deposited during the last ice age. And I also went to Iceland and had a look at the sediments there. Although I found some really interesting things in the geology of the rocks and the sediments underneath the glaciers, I didn't really find any kind of conclusive evidence that melting would cause that glacier to
Mm.
flow faster on top of its sediment bed. What was really interesting was, as the glacier moved over its very soft sediment layer, the grains in the sediments would line up like ball bearings into bridges. And because of all of that strength and the pressure of the ice flow over those sediments, it would cause these bridges of grains to break. And what I was hypothesizing was that would cause the glacier to flow faster. But what I realized at the end was it was really difficult to measure that. I could see these bridges of
Mm.
grains like ball bearings getting together as the ice moved over. But it was a very difficult theory to prove in the
Yeah.
end. But I did love the process of researching it.
Mm.
How have the perceptions of geology from the general public and the diversity within the subject changed over your careers? And
Oh, so go on, Ollie.
oh, and also, what would you have been? oh, What would have been the main challenges you faced in geoscience communication?
Yeah, it's one of the key things I've really battled with is to help people understand and value that rocks are part of the natural world. And I'll say this over and over again: people walk about in nature, and all the programs that you see on television always talk about wildlife and plants and trees and the living parts of the natural world, but no one ever seems to realize that the rocks are there supporting all life on earth. And one of the biggest challenges I've had in my career is to help people appreciate and understand that the rocks matter just as much as all of these incredible things that we value, like wildlife and plants and trees and butterflies and insects. And the reason I believe for that disconnection is that rocks just exist. Here's a piece of granite and I'm holding it, and it doesn't move and it doesn't breathe and it doesn't change very much over time. In fact, it changes over time so slowly, it's hard for us to comprehend. And because of that, it's really hard to get people to understand that their stories are amazing, and also they are a really critical part of the natural world. That's probably the biggest challenge I've had as a woman working in science, and particularly as a woman of color. There's not very many of us working in the field, in the scientific field, but also in the spaces where I moved into, which was conservation of protected landscapes. So you're very isolated. You're pretty much on your own, and you have to really be quite a strong person to be in the meeting rooms and to say what you think and to be confident about putting your opinion across. And I would say that's probably been the hardest thing about doing this job, is being on my own. Because sometimes people will think that, you know, if you're a woman or if you're a woman of color, you're coming from a certain place and that your opinions don't matter so much, or things that you'll describe about your experiences are less important than other people's. And so just working in an environment and a sector like this has been very challenging. But I've done so much work over the last 20 years to try to make it easier for other young people who'd like a career in geosciences. I've kind of had to break through all those obstacles and barriers to make it easier if you want a career just like mine.
Could you explain the process of conducting geological research?
Yeah, to be a scientific researcher, and particularly somebody who's working in geology, you have to have a brilliant imagination. You've got to be super, super creative in the way you think and the way you join the dots up. And the reason why I say this is because when I'm holding a rock like, let me choose one actually. This is a good one. When I'm holding a rock like this is a beautiful rock. This is from Norway. It's green in color. And what's beautiful about it is it's got this really interesting zigzag pattern in its texture. See if I can hold that up to the camera. There you go. It's got a zigzag texture. And in order for a geologist to interpret the story of this rock, we have to use our senses. We've got to look at the rock, we've got to look at the textures, we've got to feel the rock and understand, how has it come to look like this? To have that sense of understanding, you've got to have a really vivid imagination. So when I'm looking at rocks like this, one of the key skills is you're curious, you're questioning, you've got a very visual mind to understand processes that we're not seeing at the Earth's surface. And I'll just explain that with this rock as an example. Here you go. You can really see those folds in the rock, can't you? Look at that zigzag line. Now, in my hand, if I told you I was holding the moment when a mountain was born, that gives you some idea of how brilliant your imagination has to be to bring these stories to life. So this is a green schist, and it originally started life as this rock. This is a mudstone. This is a siltstone, and this is from Cornwall. Okay, these guys, this formed around about 350 million years ago. So this siltstone, and what you can see are these amazing layers in the rock. They're almost paper thin. And these layers were formed at the bottom of a seabed, an ocean called the Iapetus Ocean. So these are muds that are very finely building up on the bottom of the sea floor. Now, the Iapetus Ocean was surrounded by two continents, and they were very, very slowly moving together like this and would collide over time. The ocean was in the middle between them. And as these two continents, Laurentia and Baltica, so Laurentia became North America and Baltica became Scandinavia, as these two continents gradually kind of collided over about 150 million years, this seabed sediment in my hand became squashed, and it was uplifted, squashed and squeezed under immense pressure and heat, and it transformed into this rock, a green schist. And what's remarkable is that when those seabed sediments were pushed and squeezed and changed under heat and pressure, they were pushed upwards to form an amazing mountain chain. And that's what I mean when I say that in my hand, I'm holding the moment when a mountain was born. It's amazing, isn't it?
Yeah.
How do you think geology shapes civilizations and cultures?
I think it has a really profound impact, particularly on cultures that have stories that go back almost 30,000 years ago. And a lot of these ancient cultures, indigenous people, have lived in nature and lived alongside rocks for tens of thousands of years. So they have a really deep understanding of how the rocks have always been there, manifesting their own and
Mm.
reflecting their own existence. And there's some beautiful stories that I've written about in the Whispers of Rock. One of them in particular, I really love it. It's from Yosemite National Park in California, and it's a story about the origins of a half dome. And if you know half dome,
Mm.
they used a profile of half dome for the North Face logo. So it's kind of like curved on one side and it's got a flat face on the other. And half dome is an intrusion of is formed from an intrusion of magma into the Earth's crust. That magma cools over time to form a great big block of granite. And what I love about this particular story about how the Awinichi people who lived in Yosemite Valley for 6,000 years, I love this story about how they imagined this peak of granite as a living person. And the story goes as follows. There was a man and a woman who were walking through the Yosemite Valley. Um, and they were very hungry and very tired. The woman was carrying a basket and her husband was carrying a stick. And as they were walking, the woman kind of walked on ahead and she saw a lake, and she was so thirsty she dipped her head and began to drink the water from the lake. And she was so thirsty she drank the lake dry. When her husband arrived, he was really angry because he was really thirsty as well. And he said to his wife, "Why didn't you leave me any water?" So they started to have this huge argument. And the man reached for his stick to kind of beat his wife. And she was so terrified and angry that she ran away from him with tears streaming down her face. And she threw her basket back at him in kind of anger. And now the Great Spirit, who was looking at this whole argument unfold, he got really angry. He was thinking that people should be kind to each other. And so, as a lesson to everybody else on earth, he turned these two people into rocks. The husband became Washington Tower, which is on one side of the Yosemite Valley, and the woman became Half Dome, and her indigenous name is Tisayak. And the really beautiful thing about this story is that the indigenous people, the Awanichi people, they could see her tears on the face of the rock. And these tears are black. They streak the grey rock black. But the tears are also lichen. And so what scientists know is that the story is about 6,000 years old, and that means that the lichen have been growing on the rock for that long. And it's amazing how the two stories and the science intertwine with each other.
What would you say are the most significant unsolved mysteries in geology and paleontology?
Oh, this is an interesting one because, I think we're still looking for evidence for the origins of our Earth. How did this big ball of gas and dust and matter coalesce to form this incredible planet? And I think there are minerals, and in fact, I've got a rock here. This is called a Lewisian gneiss. It's from the Western Isles of Scotland. There's a mineral in here called zircon, and
Mm.
zircon helps us understand the age of the Earth. So inside this rock, the zircon has been dated in other rocks, of course, because you need to crush the rock up and extract
Mm.
the mineral in order to do the radioactive nuclide dating. The zircon minerals have been dated to 2.7 billion years old. So this rock in my hand predates life. It is absolutely ancient. And I think what researchers are still trying to do is understand what the world looked like in these very, very infant
Mm.
phases, in the first, you know, half a billion years that the world was evolving and changing. We're still looking for more evidence of rocks like this that will help us understand how the earth was forming and developing, and things like creating water and oxygen. Where did all that come from? We have a little bit of understanding of that, but just that kind of early understanding of what did the planet look like.
Yeah, that was really interesting. This is my final question. What advice would you give to young people interested in pursuing a career in geoscience field?
Oh, I would say this is the easiest thing you can do, is just look at the rocks around you and try and see if you can understand the stories that they're revealing to you. And you don't need to be somewhere like the Jurassic Coast, although that is a brilliant place to go and look at rocks. You can be in your library, your local town, you can be at school, you can be walking in your local park, because the best thing about geology is that the rocks are everywhere. They're all around you, and all you need to do is pick one up, uh, and look at it and look at its color, texture, and form. And if it's a crystalline rock like granite, there are loads of
Mhm.
crystals in this. It's really sparkly and shiny. It's telling you a story about magma that intruded into the Earth's crust. It couldn't go all the way through like a volcano and erupt as lava. It got trapped, and it took about 2 to 3 million years to cool down, and it formed this rock. Um, and those are the stories. Those are the incredible stories that rocks can tell you. And I just love the fact that they're all around you. You could be walking down your high street. All you need to do is look at the building stones of the buildings around you, and you will see a rock. And if you take a picture of it and you take it home and you're looking it up on the internet or in a book, you will find out its magical story.
Thank you so much for coming and talking to us today.
Oh, my pleasure. Thank you for having me.